Okay, let's unpack this. For, the last couple of years, the headlines have just been nonstop about AI's potential, right? Like instant transformation.
Yeah, revolutionary potential. That's the phrase you always hear.
Exactly. But the reality, hitting boardrooms right now, it sounds incredibly painful.
It really is.
So today, we're doing a deep dive into, surviving what looks like a looming AI bubble. And we want to give you the shortcut, really, to understanding the real problem behind it, which seems to be architectural failure.
That's the core of it. And we have to start with this brutal statistic. It's quite stark.
Okay.
While everyone's talking about pouring money in, something like 95% of organizations, they're reporting near zero, or actually zero, measurable return on investment from their generative AI project.
95%.
95. And this is despite, collective enterprise investment hitting somewhere between 24 and 32 billion. Huge sums.
Wow. That's a staggering lack of return. If that much money is going in, where's the value just vanishing? It sounds, exactly like a tech bubble, right? Inflated hopes hitting a wall.
It does sound like that. But we need to be really clear about the kind of AI bubble this is. It's not really that the tech itself, the AI capability, is overhyped. LLMs, they're genuinely powerful. Okay. The problem is systemic. It's rooted deep down in, fundamental architectural debt. Old systems, bad data flows. That's what's actively stopping companies from getting any real value out.
So like trying to put a jet engine on a horse-drawn cart.
That's a pretty good analogy, actually. Organizations thought they could just bolt this state-of-the-art AI onto, maybe 1980s infrastructure and expect it to just work. It's a massive engineering discipline challenge.
Right, so failure of the foundation, not the engine itself.
Yeah.
Where did things go wrong in that first sort of mad rush?
It really started with what you could call the model-first approach. After ChatGPT exploded, you had executives basically running around asking, okay, what's our LLM strategy? What's our ChatGPT strategy?
Okay, get the tool first.
Exactly. Buy the shiny tool before checking if the workshop is even wired correctly. And the foundational requirement that just got skipped over is this core truth. The performance, the accuracy, the reliability of any AI system, it depends entirely 100% on the quality and accessibility of the data it uses.
And neglecting that's created what some are calling the trillion-dollar data problem. Is that even fixable now? Or is it too late?
Oh, it's fixable. But it needs pretty painful immediate surgery. The research is quite clear on this. By 2026, a huge number, like 80% of organizations trying to scale AI, they're going to fail.
80%. Why?
Specifically because they refuse or maybe can't modernize their data governance and their underlying infrastructure. And this refusal, it kind of manifests as this three-headed hydra of data dysfunction that's just churking the life out of AI projects.
A three-headed hydra. Okay, let's tackle this beast. Head number one.
Head number one is the silo problem. This is basic but critical. Your organization's most valuable asset, often its intellectual property, its unique knowledge, it's trapped.
Trapped where?
Stuck in, decade-old ERP systems, buried deep in unstructured PDFs that nobody can search properly, maybe locked away in ancient SAP databases, or just fragmented across loads of different source tools that don't talk to each other.
Right, so the AI can't learn from what the company actually knows.
Exactly. An LLM can't create value from knowledge. It literally cannot access. It's like, imagine having this amazing library, but all the doors are locked. So the AI just has to rely on, general public knowledge instead of your specific expertise.
Okay, that makes sense. And head number two. This is where it gets actively damaging, right? The garbage in, garbage out amplification.
Yeah, this is crucial. Standard computing, it's somewhat forgiving of messy data. AI is not at all. If you feed an LLM messy, biased, incomplete, or just plain unverified data, it doesn't just shrug or give an error message. No, it takes that garbage and it amplifies it. And it does so with this unnerving confidence.
So it doesn't say, I don't know.
Rarely. It'll hallucinate. It'll confidently invent the wrong answer based on the bad data and present it as fact. And that creates huge, sometimes irreversible business risks, especially if those wrong outputs feed into automated systems that affect customers or finances, big decisions being made on faulty AI output.
Scare stuff. Okay, and the final head. This one addresses the future of AI, you say.
Yeah.
The real-time deficit. So this isn't bad data, it's slow data.
Exactly. Slow data, stale data. The next big wave in AI is what we call agentic AI.
Agentic, meaning?
Proactive autonomous systems.
Yeah.
AI that can work on its own to achieve multi-step goals you set for it.
Okay.
Now, Imagine an AI agent needs to make a decision right now.
Yeah.
Maybe check current inventory levels instantly to reroute a shipment, or approve a high-value bank transaction based on the account activity from the last, say, 5 minutes.
Yeah, needs up to the second info.
Precisely. But traditional data infrastructure, it often relies on these nightly batch jobs. Data gets updated once every 12 or 24 hours.
Which is useless for real-time decisions.
Totally obsolete for this kind of AI. That 12-hour delay means the agent is making decisions based on old, potentially inaccurate information. And that delay, that could easily be $1 million failure just waiting to happen.
Okay, so that paints a pretty bleak picture of the current foundation. Based on that systemic failure, what does the architectural solution look like? We have to pivot, right? Away from batch ETL. That's extract, transform, load the old way.
Decades-old process, yeah.
And those, you mentioned, obsolete Hadoop stacks,
Hmm.
the old big data storage.
That's right. The whole industry is rapidly moving, or needs to move, towards architectures built on real-time streaming data. Think data flowing continuously. Also, centralized lakehouses and really stringent automated metadata governance.
Lakehouses, not data warehouses or data lakes.
Correct. For listeners maybe less familiar, we're moving away from older models like separate data warehouses for structured data and data lakes for unstructured stuff. A lakehouse is a unified architecture. It combines the scalability and flexibility of a data lake with the structure and governance features of a data warehouse.
So, one place for all data, structured for use, reliably governed.
Exactly. It makes data instantly usable for analytics and AI without sacrificing control. This is a fundamental maturing of the whole data engineering field.
And this shift, it changes the job for data professionals entirely, doesn't it? It's less about just writing code.
Much less. It's now about high-level architectural thinking, designing and maintaining these reliable platforms that can guarantee data quality and speed, especially for these demanding AI workloads. You're building the foundation.
So how does a listener, maybe listening right now, start actually implementing this AI factory model you mentioned? Where do they begin next week?
Right, the AI factory model. That's really the emerging architecture designed to handle AI at production scale, fixing those fragmented data pipelines we talked about.
So less like a traditional warehouse,
More like an integrated, continuous assembly line for knowledge. That's a good way to think of it. It requires unified data access across the board. And the architecture itself has to be designed to seamlessly take raw enterprise data and transform it into AI-ready assets. Crucially, without compromising security or needing to duplicate storage all over the place.
So the same data pool serves multiple needs.
Yes. If your organization needs the same customer data for, say, quarterly reports, for your business intelligence dashboards, and for real-time AI agents making decisions, it absolutely must be managed centrally under this unified model. One source of truth.
Makes sense. And getting that deep infrastructure convergence right, it seems like it needs some key capabilities. You mentioned 3.
Yeah, 3 critical capabilities, really. First, unified management and scalability. We need systems with native integration to drastically cut down complexity and stop needing tons of custom coding just to connect things.
Okay. Number 2.
Second is core AI infrastructure convergence. This means building secure foundations specifically designed to support AI's unique needs, robust security, constant observability, managing the heavy compute demands. It's specialized infrastructure.
And third,
policy-driven networking. This is absolutely key for governance. It ensures that your security rules, your compliance policies, they automatically travel with the data and the workload wherever it goes across your own data centers into different clouds, even out to edge devices.
So if regulated data moves, the rules follow it automatically.
That's the goal, non-negotiable for compliance.
Okay, so fixing the data infrastructure, that's one massive architectural investment. Let's flip to the other side of the ledger. The actual operational cost of running these huge large language models.
Yeah.
The cloud bills, the processing time, that's forcing an economic shift too, isn't it?
Absolutely. That's a huge driver right now. The cost of just running inference, getting an answer or output from a big general purpose LLM, that alone can often kill the profitability of an enterprise AI application before it even starts.
So economics are pushing change.
Definitely. And this economic pressure is precisely what's fueling the rapid, very pragmatic rise of small language models, or SLM.
Right, SLMs. Remind us, what's the definition there? And why are they so pragmatic?
So SLMs generally have fewer than, say, 10 billion parameters,
Yeah.
much smaller than the giants. And the crucial thing is they can often deliver similar, sometimes even better, results for specific, specialized tasks within a business.
Like customer support AI or compliance checking?
Exactly, those kinds of things. But they do it at a fraction of the computational cost, a fraction of the cloud bill. It's basically right-sizing the tool for the job. You don't need a massive general-purpose brain when a specialized, efficient tool will do.
And that right sizing gives other advantages too, right?
Yeah.
Lower latency, if it's on edge devices maybe, privacy.
Huge advantages there. Lower cost, faster responses, lower latency. And yes, suitability for edge computing is key. Plus, for privacy-critical industries, think finance or healthcare, processing data locally using an SLM, maybe on-premises or even on the device itself, is vital. It minimizes how much sensitive data you expose.
Makes sense. Are there other ways costs are being cut beyond just using smaller models?
Yes, definitely. We're seeing optimization techniques really starting to define the efforts for, say, 2026. Two big ones are mixture of expert, MOE, and model merging.
Okay, MOE and model merging. How did those actually help cut costs? They sound a bit abstract.
They're essentially clever ways to get big model performance without the full big model cost. Mixture of experts, or MOE, is fascinating. Instead of running the entire massive model every single time you ask it something,
Which is expensive.
very expensive,
Yeah.
MOE is designed so that only a small part of the model, the specific components, the experts that are relevant to your particular query, gets activated.
So only using the bits you need for that specific task.
Exactly. It drastically reduces the compute needed each time, and therefore the cost. And model merging is kind of what it sounds like. It involves combining two or more smaller, specialized models. The idea is to get the breadth of capability you might find in a larger model, but without that larger model's running costs.
Interesting efficiency hacks. Now, let's pivot slightly to compliance. You mentioned it earlier, but it feels like this has shifted dramatically recently. Things like the EU AI Act, moving from discussion to actual enforcement. It's making compliance less of a policy paper and more of an architectural must-have for survival, isn't it?
That's absolutely correct. Governance isn't just a checklist for the legal team anymore. It has to be baked in, an ongoing, embedded function within the architecture itself. Your architectural choices are now directly driven by whether you can survive regulatory scrutiny.
So survival depends on building compliance from the start.
Yes. And this demands a whole new set of mandatory controls built right into the systems, non-negotiable.
Okay, let's run through those required controls. First up, data provenance.
We need full data lineage tracking. That's the ability to prove, without a shadow of a doubt, exactly which data sets contributed to every single output the model generates. Think immutable, signed logs. Essential for audits, for explainability, for debugging.
Got it. What's next?
Next, network isolation. This means implementing things like private network connections when you're accessing AI services hosted in the cloud.
Why is that isolation so critical, practically speaking?
Well, think about protecting your sensitive data, maybe proprietary client information or regulated health data. When you send a query to an LLM hosted, say, in a public cloud vendor's environment, you absolutely must guarantee that that sensitive traffic never travels over the public internet. Private links, secure tunnels, essential.
Makes sense. Keep it off the open road. What else?
Then, because AI can have real-world impacts on people's rights or safety, we absolutely require human-in-the-loop checkpoints.
So building in points where a human has to review and approve.
Exactly. Architecting specific review and override capabilities, especially for any workflow that impacts safety, fundamental rights, or involves significant financial outcomes. It guarantees human oversight where it matters most.
Critical safeguard. And finally,
automated risk control. This means building continuous processes like bias detection pipelines into your system and also setting up red teaming environments.
red teaming, like security testing.
Yeah, basically adversarial testing.
Yeah.
Purposefully trying to break the AI, find its weaknesses, identify potential harms before it gets deployed, and continuing that testing even after it's live. It's about proactive risk management.
Okay, comprehensive. Now, looking ahead again, you mentioned agentic AI earlier, moving beyond just reactive models that answer one prompt.
Right, moving to systems capable of working autonomously, proactively towards goals you give them, multi-step tasks.
How does that actually work architecturally? What enables that shift?
The key enabling architecture there is something called agentic retrieval augmented generation, or agentic RAG. Now, standard RAG, you might know, connects an LLM to a knowledge base, like your company's documents.
You give it better, more grounded answers, right?
Exactly. Standard RAG is like a smart lookup tool. It finds the best document or data to help answer your specific question.
Okay, and agentic RAG. That sounds like a step up.
It's a major step up. Think of agentic RAG not just as a lookup tool, but as a project manager. It integrates AI agents, these autonomous components that can figure out and then execute complex plans on their own.
So not just answering a question, but doing things.
Yes. Instead of just finding information, an agentic system might take a high-level goal, like resolve this customer shipping issue. It might then autonomously decide it needs to check the external shipping company's API, then pull the customer record from your internal database, then draft a support ticket summarizing the findings, and maybe even trigger a specific workflow to initiate a replacement shipment, all without needing a human to step in at each stage.
Wow. Okay, that really raises the bar for the data infrastructure again, doesn't it? It reinforces that need for the real-time, accessible data we talked about earlier.
Absolutely. If the agent needs to check inventory now, it needs the data now. Stale data breaks the whole process.
And does this agentic future link back to the SLM discussion?
It does, very strongly. It reinforces that strategic pragmatism. Since these agents often perform relatively narrow, specific, repeatable subtasks like check inventory or draft ticket, the most efficient and cost-effective approach is often an SLM-first strategy.
Use the small, specialized models for the specific agent tasks.
Precisely. You reserve the big, expensive, general-purpose LLMs only for the parts of the process that genuinely require complex, open-ended reasoning or maybe understanding very nuanced human language. But the bulk of the agent work, that can often be handled much more cheaply and efficiently by specialized SLMs.
Right, pragmatic choices again.
Yeah.
Okay, so bringing this all together, what does this mean for you, the listener, trying to navigate this? It sounds like 5 clear strategic imperatives are emerging for, say, 2026, based on this whole architectural realignment.
Yeah, I think we can boil it down to 5 key things. First, mandate architectural debt resolution. Seriously, stop launching new AI proofs of concept that rely on those old, slow, traditional batch ETL pipelines. All strategic capital needs to go towards building those modern AI factory foundations, emphasizing real-time streaming data. Fix the plumbing first.
Okay, imperative 1, fix the foundation. Number 2.
Second, institutionalize economic pragmatism. Fully adopt that SLM-first strategy for new projects. Focus relentlessly on cost efficiency and suitability for edge deployment, and actively explore and implement those optimization techniques like MOE and model merging. Be smart about the economics.
Right-size the tools. Optimize the usage. Got it. Third,
Align development with vertical specialization. Don't try to build generic, do everything AI. Focus your resources on specialized vertical AI systems, the ones that solve high-impact, industry-specific problems for your business. That's where the real ROI is narrow, deep applications, not broad, shallow ones.
makes sense. Solve specific pains. Fourth, imperative.
Fourth, embed compliance architecturally. Treat regulatory requirements, things like the EU AI Act, as non-negotiable design constraints from day one. That means things like private network connectivity for cloud AI and full data lineage tracking. They aren't nice-to-haves. They are foundational requirements you build in from the start.
Compliance by design, not as an afterthought. Okay, and the 5th.
And finally, number 5, adopt synthetic data as a core strategy. Start integrating synthetic data generation tools and techniques alongside privacy-enhancing technologies. This is crucial for overcoming data scarcity, especially when training models without falling foul of privacy regulations or exposing sensitive real data.
Use safe, artificial data to train models when real data is too scarce or risky.
Exactly. It's becoming a core part of the toolkit for responsible AI development.
So to sum up, this widespread failure to get ROI from AI, it really boils down to a critical engineering gap, doesn't it? Obsolete data infrastructure, maybe too much faith put in the shiny models rather than the unglamorous work of data integrity and governance.
That's precisely it. Success going forward, it's going to be determined by treating governance, data quality, security, treating them as core architectural features, not as bolt-ons or legal tick boxes you worry about later. The market correction that's happening now, heading into 2026, it's really an enforced maturation. The economics and the regulators are forcing the entire AI lifecycle to grow up fast.
So the question isn't if your organization will be affected by this transformation, it's whether you'll be prepared to actually lead it. And here's maybe a final thought for you to mull over. If the stats are right, and maybe 80% of organizations fail to scale AI effectively because of this infrastructure debt, who are the winners actually competing against?
Yes, that's a powerful point.
They're competing against the 20% who did make the shift. who already moved to real-time systems, who embedded governance. That fundamental architectural difference, that's looking like the real competitive moat for the next decade.